So students, let's come back and start with the preparation of carboxylic acids. Right. So when I speak about carboxylic acids, let us write the heading: preparations of carboxylic acids. Right. So basically, I said we are going to prepare carboxylic acids by oxidation, hydrolysis, isn't it? Then I said from Grignard's reagent. Then I said we'll also be preparing from alkenes, isn't it? So let us start with the first one, oxidation. So whenever you're oxidizing or oxidation process, you require an oxidizing agent, isn't it? So you can use oxidizing agents like K2Cr2O7. Okay. Suppose if I'm using KMnO4, I can use KMnO4 in both. It can be used in acidic medium as well as it can be used in alkaline medium. So not a problem to use any of those. The mediums, right? So when I speak about oxidation, the most important thing is I am going to oxidize from alcohols, but especially alcohols that took primary alcohols. Remember that. Why? Let me write a general reaction now. When I'm writing a general reaction, right? So I'm going to take a primary alcohol. Isn't it primary alcohol? Because it has two hydrogens attached to the functional group. Yes. Now I'm going to introduce or add or oxidize it. When you're adding, you very well know oxidation is a process of removal of hydrogen or addition of oxygen. So this hydrogen adjacent to your functional group is going to get eliminated, right? So the one which is adjacent to this. So what do I get? When I rearrange, I get RCHO. Correct. Now this is an alcohol. Which alcohol? Primary alcohol. This is an aldehyde. Now this I'm further oxidizing it. So when you're further oxidizing, this goes and adds to this addition of oxygen. This becomes RCOH acid. That is how we are prepared. So from primary alcohol, let us take an example. I'm going to take an example now. CH3 CH2OH. Yes, I'm going to oxidize this. So what do I get? Elimination of hydrogen. I get CH3, CHO. I'm going to further oxidize this. Addition of oxygen. CH3, CHO. That's it. We have prepared acid. Let us name this. This is 2 carbon. So it is ethanol. This is 2 carbon ethanol. This is again 2 carbon ethanoic acid or acetic acid. Simple as that. Yes, we have taken primary alcohols and we have done, and simple. Let us do one more. Suppose if I am going to take 1, 2, 3, 4 like this. Okay. So CH3, CH2, CH2. So what is this compound? 1, 2, 3, 4. So this is butanol. Is this primary? It is primary, isn't it? So when I'm going to oxidize this hydrogen adjacent to the oxygen is eliminated or gets eliminated. What do we get? 1, 2, 3 CHO. Right? So fill in all the hydrogens. Yeah. How much did I get? 1, 2, 3, 4. This is also 4. This is also 4. So this is butanol. Right? This on further oxidation goes and adds here. I get 1, 2, 3 COH. Again count 1, 2, 3, 4. Butanoic acid. So what am I trying to explain? On oxidation, the alcohol, how many are there? 1, 2, 3, 4. The same number of carbon atoms will also appear on further oxidation. You will get an acid with same number of carbon atoms. Done? This is simple. Right. Let us erase this and come back and do oxidation of aldehyde now. We've already done. We'll again do it. Yes. So now I have to do the heading. It's the same. What I have done, I've been doing the same since so many chapters, but okay, not a problem. So second thing, from aldehydes. So aldehydes, when I speak about aldehydes, let us write the general reaction. Now RCHO. Correct? So RCHO on oxidation gives me RCOH. This is aldehyde. This is acid. Simple. Yeah, so you can use oxidizing agent, suppose KMnO4 in the presence of OH minus. I'm using alkaline medium. Now when I take an example, CH3, CH2, CHO. Okay, this is an aldehyde. Which aldehyde? Okay, no, not a problem. Primary only I put. Then I wrote I am going to oxidize in the presence of KMnO4 and OH minus. Removal of hydrogen. I'm going to get CH3. Now observe carefully, this is removed. So what do you get? CH3, CHO. right? No. CH3COH, no? This should not be removed. What should I do? I did a mistake. I have to add oxygen. Yes, I did a mistake. Please remember. So what should I do? This is aldehyde, isn't it? Oxygen should get added, not removed. Please note that. What will I get? I get CH3CH2COH. So this is 1, 2, 3. So what is this? Propanol. What is this? 1, 2, 3. So propanoic acid. So the same number of carbon atoms. I'm sorry, I did a mistake last this one. So please note it. So this is from your aldehydes, right? Now when I take a ketone, what's going to happen? Let us prepare a ketone now. Let us prepare an acid from ketone. So when I speak about oxidation, that is you're preparing this one from ketones. Remember, ketones, they undergo oxidation only under drastic conditions. Remember, they undergo under drastic conditions only. So you have to be careful while doing this. I'm just giving the general reaction for this. So basically, suppose if I have and group like this, okay, this is like this, okay. Now what happens when you're trying to oxidize this? This is a ketone, isn't it? RCH2COR. It is a ketone. So this is going to break up and generally form two types of acids. Let's suppose if I take this as R prime, it's going to form one type, is going to form like this, and the other type would be this. Basically unsymmetrical. So you get two different types of acids. So I'm not showing this reaction because the conditions or the reaction conditions should be very drastic. That is the reason I'm not specifically showing this particular reaction. Done. Now let us come back and do the next type of oxidation, that is from alkyl benzene. Okay, what is alkyl benzene? So when I speak about alkyl benzene, just as it says, now this is your benzene, isn't it? Right. Now to this, I'm going to add an alkyl group. What is alkyl group? Methane. Suppose methane is an alkane, one hydrogen less, it is alkyl, that is methyl, right? So I'm going to add one CH3. So what is this? This one called? It is called toluene, correct? Toluene, we call it as toluene or toluene. So this is which benzene? Again an alkyl benzene. Now suppose if I have one more alkyl benzene, what am I going to do? I'm going to take benzene 1, 2, 3, 4, 5. Suppose, right? CH3, CH2, 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 now CH2. Right. Which benzene is this one? Okay, let us number this 1, 1, 2, 3, 4, 5. Correct. So it is pentyl, right? Pentyl benzene. So you have 5 carbons, so pentyl group, right? Now, if I take this compound, which compound? Now, one CH3 here, one CH3 here, right? This is orthoxylene. Now, all these compounds are alkyl benzenes, all alkyl benzenes, isn't it? When you oxidize this, or when you oxidize this, or when you oxidize this in the presence of oxidizing agents, irrespective of the side chain, remember I'm saying something, irrespective of the alkyl chain, here it is only 1, here it is 5, here it is alkyl group, irrespective of the chain, it is only going to form whether this or this, it's only going to form one carboxylic acid. Remember this in the exam. Let it be how many? Don't try to change everything. Irrespective of the carbon chain, it's going to form acid. Now suppose here you have 2 groups, isn't it? Here it's going to form, this is only one chain, so one carbon, one carboxylic acid. Here, this is what it forms. So remember, irrespective of the chain, it's going to form one here, and because 2 methyl groups, it's going to form this. So we have done with the oxidation of alcohols, aldehydes, ketones, and alkyl benenes. I'll meet again with the hydrolysis of your cyanides, that is nitriles, and also we're going to study hydrolysis about esters.